Solid Edge continues to set the standard for streamlining 3D designs of products, whether they're a single part or an assembly of over 500,000 components. In this demonstration, we'll show how Solid Edge ST7 speeds design of areas around a bulldozer engine. First, we'll work on the engine mounts. This engine has 4 mount locations, and the appropriate bushings, washers, tension, and mounting bolts are organized into a single subassembly, which we've placed in one location. First, we'll grab the 4 sets of mounting bolts and washers by selecting one set, then use Select All Identical Parts to include the other 3. We'll also select the tension bolt, washers, and bushings within the mounting assembly. Watch as we use Duplicate Components to copy all of the selected hardware from the initial position to a second position. Note the preview of the duplicate. A valuable option within this command is Select Matching Occurrences, which finds the 3rd and 4th mounting positions towards the rear of the engine. Very smart and very fast. Impressive real-time rendering capabilities are now available within Solid Edge ST7, courtesy of KeyShot. This easy-to-use but powerful application is integrated into Solid Edge for advanced photorealistic visualizations of your 3D design, without ever leaving the modeling environment. Again, working with the bulldozer engine, we'll open its turbocharger assembly. KeyShot is available from the Solid Edge command ribbon and will open the turbocharger into a separate rendering window. Appropriate colors and materials are automatically transferred from the modeling environment, though you can also assign materials and colors from KeyShot, and watch the turbocharger update before your eyes. Getting back to modeling, we want to be able to rotate one port of the wastegate tube. As we grab it and rotate, you can see the tube itself lengthens. In real life, this tube would be cut to a specific length and would not elongate. You can model that realistic behavior by editing the tube's underlying key point curve and selecting the new option, Curve Length Step. The new Fixed Length option allows us to define a finite length of the curve, which ensures the tube length is fixed as well. We can even constrain the curve to only move in a specific direction, a great option to replicate conditions under which the turbocharger is actually maintained. So you can use the 3D model to develop maintenance documents for the real component. Returning to the assembly, watch as we rotate the intake port. The tube's length remains fixed as it would in a real system. Let's go back to KeyShot, but first we'll select KeyShot Update to ensure all of the model changes propagated to the rendering. The resulting realistic imagery could greatly enhance any equipment maintenance manuals. Now we want to build an engine test stand. For this, we'll use the frame construction tools within Solid Edge ST7. We'll begin with a solid representation of the test stand and use the edges of these bodies to guide frame creation. The frame command allows you to set a preferred orientation so you get mitered corners placed how you want the first time. Select the solid body and Solid Edge automatically places members based on your preferred orientation. Let's remove the center member so it won't interfere with the engine. While we're creating frame members, we can switch between single, chain, face, and body options to get the custom framework for our engine test stand. We'll place more members to connect the front and back of the stand. Once complete, we'll display the engine and determine how it fits on the stand. In the front, the frame needs to meet up with these mounts, so we'll use the Synchronous Modeling to move a face of the solid and thus the frame to match them up. With ST7, we listen to our customers' needs and have delivered a fast, flexible, and more intuitive suite of product modeling tools, which allow you to focus more on your designs and less on the tools. Solid Edge. Design better.